Okay, team, hey, here is our Chapter 5 review worksheet. Chapter 5, we covered 3 different methods to solving systems of equations. We did the graphing method, which is 5.1, substitution method, which is 5.2, and the elimination method that is 5.3. Now, each of these methods works better depending on the type of systems of equations that you have. And by the way, on your Chapter 5 quiz, to get an A, you have to be able to do all 3 methods. Now, a graphing method, this works best if you have a graph. It also works best if both of your lines are in what's called slope-intercept form. This equation, or this system rather, both of these are in slope-intercept form, so this works well. So to solve using graphing, I'm going to start with the y-intercept. It's my start, starting here at 4. And then the number with the x, that's the slope. That tells me how to find another point on the line. So I started up at 4. I'm going to go down 2 over 3, down 2 over 3. And there's one line. Okay, if I want to graph the second line, I'm going to start at -4 on the y-axis, so -1, 2, 3, 4, and a slope of 2. And just so you know, if it's not a fraction, you can just give it a denominator of 1. So I need to start at -4. I need to go up 2 over 1, up 1, 2 over 1, up 2 over 1, up 2 over 1. And this is how I'm going to solve the system. The solution is just where the 2 lines intersect. So in this case, it would be 3, 2. That is the solution. Okay, now I'll also mention this. If you can't print out this worksheet and it's too much and you don't have any graph paper, then something you can do if you want to use the graphing method is you can go to page 117 in your book. And there are a few coordinate planes here that you can use, just so you know. So there's the graphing method. All right, substitution method. Now this works well. You want to use substitution when at least one variable is by itself. Now, if I look real close, first equation, none of these variables are by themselves. But in the second equation, I do have an x. I have an x by itself, totally by itself. So substitution is going to work well. And so for that reason, I'm going to take this whole expression for x right here, and I'm going to put it into my other equation where the x is. So let's go ahead and copy this equation then down here, -4x plus, oh, dang it, I messed up, darn it, because the x shouldn't be there. I have to scribble that out. -4x, I'm leaving a big blank spot, plus 8, y equals 8. And that's because instead of x, I need this new expression, 4x, -2y plus 6. All right, now, my next video, I'll show you I'll finish solving this one, but that is substitution. So find a variable by itself, take the expression for that variable, and put it into your other equation. All right, elimination. Elimination works well when your equations are like perfectly lined up. So the x term is above the x, the y term is above the y, equal sign above equal sign, and constant above constant. That works well. Now, I need to choose to add these equations together or to subtract them. And basically the trick is I want to find the variable term that's the same. So 3 and 2 are not the same, but 1y and 1y are the same. And because they're exactly the same, they're both positive, I want to use subtraction. If one of them was positive and one of them was negative, I'd want to use addition. But they're both positive, so I need to subtract these equations. and I'm looking right down the rows here. 3x minus negative 2x, a double negative means I'm really adding. It's 5x. Y minus y is 0. It cancels out. That's what I wanted. That's why we call it elimination. 3 minus negative 2 is minus negative is 5. Okay, divide both sides by 5 to get the x by itself. And I'm left with x equals 1x equals 1. Boom. Now I have to make sure to go back and get the y by taking my x value and substituting it into your equation. Okay. All right, I'll make one follow-up video that shows the full answers for these, and then make sure to try 1, 2, and 3 totally on your own. Okay, thanks for playing.